So here I am in my Snowden Towers electrical project. I've started a commercial design series on this. And so I'm using this to show examples of wiring, and I'm on the parking level. And if you go down here, you can see that I have a number of things circuited already. Receptacles, we've got a cab power disconnect and electrical connection. We have an elevator motor connection, and I've got home runs with circuiting information. And I just want to show that these arcs are wiring. Now, the first thing about wiring I want to show you, if you go to systems and you go over here to wire, just realize that this is not a wire. It's not a single wire. It is a group of wires, a bundle or a cable or a conduit of wires. So this represents multiple wires. And also I would recognize that not everybody shows wiring like this. Many people will just show the HDP9 next to this receptacle and just leave out the arcs. So I fully understand that there's two different ways of doing this. In my case, I still like to show a lot of arcs. I think it lends some clarity to the wiring. Now this wiring is like an annotative object. It only shows up in the view that you draw it in. So I have another view of this parking level that I call a coordination view right here, parking level plan coordination. And I use these kind of coordination views for maybe coordinating with other trades, or maybe I want to show structural on this and I wouldn't normally. Here's a view. It shows the model, but as you can see, it does not show the wiring. So wiring acts like text or any other annotative object in that respect. However, it's a hybrid. It acts like text visually, but it is still connected to the 3D device. So this wire, as you can see, a little square up here, and it's pretty small. That little square shows that this wire is actually connected to the electrical connector of this receptacle. Same thing here. It's connected to it. So it behaves like both. An annotative element only shows up in one view. However, it is connected to the 3D model logically. And that will affect us later on, as you'll see at the end of this video. This wiring can be created in a couple different ways. Let me get rid of this piece of wiring, and the tag goes with it. If I want to show wiring, I can do it manually. If I go up to the Systems tab on the ribbon, go to Wire, and I can do manually, I can do an arc wire, a spline type of wire, or a chamfered type of wire. So I can just click this arc. It says at the bottom, click to enter the wire start point. Now where do I start it? If I just start it anywhere, it's not doing anything. So when I'm putting it in manually, I'm looking now for, that's an endpoint. I'm looking for that point, number of poles. That is the connection point. And then I can pick the middle of the arc and then the end of the arc. Because I got an arrow at this end and not an arrow here, that shows that it's actually connected. And now when I click the wire, I see a square at the connection point. So that means it is electrically connected. The other way to make sure that's electrically connected is to tag it. So I can go up to the quick access, tag by category, and I have my wiring. Let's get the leader off. I have my wiring tag set up to show panel and circuit. That's if I do it manually. And I can also, if I add another receptacle, create similar, I can also manually connect from here. And I can't just connect anywhere. If I just connect anywhere, it is not actually connected. And so that gets to be a little bit deceiving. This is not connected. I actually have to get it connected to that circle. Now you can see the arrow that shows that this end is not connected to a receptacle. It's acting like a home run. So it's very tricky, I would say, to connect these manually. There's another way to connect things, and they must be on the same circuit to do so. This guy is not on a circuit. As you can see, it still has a power button up top. I need to add it to this circuit. So if we get into the circuiting aspect, click on the circuit, edit circuit. I'm adding to the circuit this receptacle, finish it. Now they are both, if I hover and tab, now they're both connected. So if I hover over this and tab a couple times, now I'm highlighting the circuit, and you can see the little pop-up says electrical circuits 9. You can see a dashed blue line right here. Do it again, which indicates that it wants to draw an arc between these two if I let it. So now I actually select the circuit by clicking on it. There's a little symbol here, little symbol. I can click on one of these to get wiring, or I can just go up top and do arc wire or chamfer wire. Now there's the chamfer, and it's more of a straight type of wiring with some bends around corners. But again, this wire now shows that I'm connected to both of these because of these little squares. So that is how you can manually or automatically draw wiring. And once this is placed, I can click on it and I can actually change it over here. See over here, I'm in the wires category. I can actually change it from chamfer back to arc. And it's only for that one instance. But now I can change it back to an arc style. And I can't change it to a spline unless I create it as a spline initially. So what does a spline look like? Systems, wire, let's try spline. Get to the connector. And then I can create kind of a path if I need to. This is a crazy path, but I can get creative with my circuiting if I need to dodge other elements. So that's what a spline does. It adds many vertices. See all these little circles? And these are vertices that you can stretch and move. Even on an arc, you have one vertex that you can move around. And furthermore, you can add vertices even to an arc. So if I right click on this, I can say insert vertex. And where do you want to insert it? Let's insert it here. So now I have control, 2 vertice control, and it kind of turns it into a spline in that case. So I can use this to go around other items. If I need to go around a corner to get to this guy, I can move it like this. If I need to move it around the corner, then I have ultimate control on this visually. As you can see, you can get crazy with paths. And it knows if I removed a wire, if I hover over this again, see, it wants to put it back. So it knows that there's no wiring here. Let's go back to the arc. Now, sometimes you'll throw an arc and this will not be where you want it. Let's say it ends up way over here. Well, I don't want it to look like that. So you can easily get to the grip. Now, it's hard to see sometimes with these thick lines. So one little tip is to go up to thin lines. Click on your wire, and now you can see the little grip much better. So that's a little tip to help you find these, to make it look right. One more pro tip I'd like to show you. Sometimes you'll find that you have an arc that's right at the connection point, and you would like to move this. Now, if I move it like this, I'm actually removing it from the connection point. And so you can see I lost my tag, it's unnamed. This wiring is not connected to my receptacle anymore. So let's get this back onto the connector. But if I want my wiring, if my wiring is there on the connector like that, it is sometimes hard to get to that circle. So what you can do is hover over it. Right now it says move vertex. I don't want to move the vertex. If I hit tab, change and offset, that is code for I'm grabbing the grip, not the connector. So now I got to the circle. Now, another point about wiring is you don't have to show every home run individually. I can combine, for example, circuit 9 and down here circuit 11. I could combine them into one home run. So what I can do is manually attach some wiring between these two circuits to get a multi-circuit home run. So let's try that. Systems wire. I'll use an arc. Connect to the connection point, the circle, center of the arc, and then there. So as you can see, because I have home runs on both, it shows a 2-arrow, 2-circuit home run. Let's move this out of the way. It added the additional hot wire in here for me to show 2 circuits. And then I can actually just delete this home run. So speaking of the hot wires, except for this multi-circuit home run, if I click here, I can actually add additional hot wires to this conduit if I need to. And it's just mostly used for lighting, when you may have a always hot and a switched leg or a switched hot, you may want to add multiple hot wires, phase conductors to this run. So you can do that with the plus and minus. Now jumping into some of these settings we talked about, if you go up to Manage, MEP Settings, Electrical Settings, you'll see there's a number of things that affect wiring. First of all, under General, clear at the bottom, there's a thing called Circuit Path Offset, 9 feet. What is that? We will get into that in a minute when I show how you can modify the circuiting path to affect your circuit length. This is a vertical offset that REVIT will add to every home run, for example, or every wiring path. It will take it up from where it is on the receptacle, for example. It'll take it up to the 9-foot level and move it horizontally and then back down. That adds your vertical offset to your wire length, to your circuiting length. And then if you go down to wiring, you get things like ambient temperatures and hot wire tick mark. I have it short, ground wire is a circle, wire, neutral is a long wire. You want a slanted line across the tick marks. So you have a lot of variety here to how you want to show the actual conductors within these conduits or cables. Where do you want to show the tick marks? Well, only on home runs, or you can always, if you want to show them in between every receptacle or every light fixture, you can do so here. Now, voltage drop. REVIT, yes, will perform some voltage drop calcs. Are they accurate? Not really, and we'll get into that. But you can set up your percent maximum voltage drops here, and then it will automatically do some wire sizing, which we'll get into. Arrows for the multi-circuits, we have it set up for multiple arrows. There's other choices. You can have a single arrow. And then what style of arrow do you want for that home run? Now, get to wire sizes. What material do you want to be the default for wire sizes? Let's say I want to go with copper. And then here's a whole chart on diameters of wire based upon their amps and the wire sizes. And so you have a lot of control over these things. Insulation types. Now, again, I don't use the voltage drop calcs in REVIT because they're not 100% accurate. But again, you have some control over these things. So you can switch these to ground, switch these to copper. Here's the wiring types, and I had added one called underground, so I can show it dashed. I've shown that in another video using filters. So that's where you get to your wiring settings. Now, I just mentioned that circuit path offset. Well, what's circuit path? Well, behind the scenes, REVIT is determining a circuit path, for example, and I'm going to disconnect these because I don't want two on this here. It's determining a circuit path from this receptacle to panel HDP, which in this case is way over here in our utility room. So here's HDP. Now it's not just figuring as the crow flies direct to direct. If you go underground, that may be appropriate. If you go overhead, it definitely is not. We typically try to follow structural lines, so we would go down and follow some lines. You can customize that path. Why would you want to do that? Let's say you want to actually try to figure out the length of this conduit run to even do your own voltage calculations. You may not want REVIT to do it, but if you want to do your own, it's helpful to have the model tell you how much length you have. So let me show you what I mean. Hover over the receptacle. I need to get to the circuit, so I hit it twice, and now I hit the circuit. Now under the system tools for the circuiting, I can go edit path. Click on edit path, and you will see right here this blue line. And so it's showing that it's going south, then it's heading east over to the panel. So it's taking kind of a direct straight line run. I can click on that and I can modify this. I can say, let's go direct underground. And we probably have a footing to dodge here with this column. And you can get that in there if you want. You can add vertices. So delete control point. If I go here, I can insert a control point. So I can get very specific with my path if I want to dodge around a footing, for example. So you can do whatever you want here. Now, let's take a look at the 3D view of this. If I go to my 3D view of this, you can see the up offset. Click on this, it's up at 9 feet because up here, my default path offset vertical is 9 feet. Now I can change that globally from that previous setting so that all offsets are at some set height. This parking garage, if you look at the section, happens to be, it's hard to tell with this model because it has multiple level 1s, but it actually goes from the parking level up to level 1 block 35, ends up being about 11 feet. So I could change this height to 11 feet. But I want to go underground. So let me change this one down to -3, for example. And look at the 3D. And you can see that drop down. And now it wants to go back up and down. So I need to change this everywhere to 3 feet below. And even this guy wants to be -3. So you can see if I forgot the minus. Let's do it right. -3, not equals. This guy needs to be -3. And there we go. We're starting to get this right. Now I can see it changed my wire length. We didn't look at this before, but here's the length of the run. Before, when it went up and over, it was like 201 feet of length. Now, because we're only going down 3 feet and coming up, it's now only 171 feet. Now you can see what it did here. It upsized the wire because what I have in this receptacle is I put in 1500. If I change this down to a 180 VA receptacle, then it would redo this wire size and would show a different voltage drop, but it's setting up for a 2.11 volt voltage drop. It may be treating this as a feeder. And that's the thing. How does it know if it's a feeder or a branch circuit? Also, for a single piece of equipment, the voltage drop gets close to right. For multiple pieces of equipment on a single circuit, it takes the entire load at the furthest away element and figures voltage drop, which of course is ultra conservative, too high of a load at too far away. So anyway, the voltage drop calcs and other videos out there mention this a lot. For a single run, it may be somewhat accurate, but at least what I like to use on this is I can use this to determine a length, and I can put that into my own voltage drop calculations without having to manually add up the length. Okay, so this last tip is very much a pro tip that I want to show you that I have not seen other people cover. As I was saying at the very beginning, these are annotative in behavior. They only show up in the view you create them. However, they are connected electrically to each other. So let me get the home run on this one again. I'm going to automatically generate it with arc wire, and I can move it around with my grip. And let's get the home run on this. Okay, I have these two circuited together. Let's say I'm in my coordination view, and for some reason I forgot what view I'm in, and I started circuiting. Let's say I want to show some wires in here as well. So I did that. I've got some arc wires. And later on, I'm working in this plan, and I'd forgotten that I'd done that. Now I say that, I want these on their own circuits. So I need to disconnect this from this circuit. So let's hover over here, click on it, and say edit circuit, and I want to remove from circuit. I want to remove this receptacle. Click on that and say, okay, I removed it from the circuit, because if I hover over this, it's not there. However, now I'm going to power this up to a different circuit. What panel? Let's go to HDP, and it's circuit 27. Well, because I still have the wiring connected, it's showing these as a multiple home run. You have to realize that I need to disconnect that. Now, even if I disconnect that here, as you can see, they are still wired together. Even though the wiring doesn't show here and I got rid of it, it is connected somewhere else in the model. And so that can really trip you up if you're trying to edit circuits and things are showing oddly. Why are both of these showing? It doesn't make sense. Well, it's because, like I say, even though they don't show here, they are still logically wired together in this other view. So until I get rid of the wiring in all these other views, now it shows properly. So if you ever have that kind of an issue, go through the model, find out where these guys are wired together in some other view because it doesn't show up here. So that's how wiring works. If you want to see more information about wiring, watch this video on how to customize the circuiting tags. Until next time.